Countdown.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Good evening, teachers, parents, and all the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, bermula percuma, selamanya percuma. How are you doing today? I hope all of you are ready for today's lesson. Before we proceed, let's begin our section by reciting a prayer for Muslim. The non-Muslim may pray according to your own religions. Let me introduce myself. I'm Teacher Kong from College Matrikulasi Perak, the moderator of today. We at Pusat Tuisyen Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revision. So, are you ready? Let me introduce our teacher for today's lesson. We have Cikgu Mawar from Ministry of Education. We are now live on Cikgu Mawar channel. Please support her channel by clicking subscribe. Now, the topic of today's lesson is Periodic Table Group 2. And together with us, we also have Cikgu Shanon from College Matrikulasi Pulau Pinang, who is control host, in charge ensure the smoothness of our lesson on technical support. And Teacher Bibi Lau from Pusat Tingkatan 6 SMK Tinggi Kelang as observer to ensure the smoothness of our lesson. So before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Stop chatting and use the chat section wisely. Number 2, regarding certificate link, the link will be given to the end of our section. Please use e-didik account when you fill in your particulars and make sure to listen to the passcode given by the presenter or me, okay, from time to time. Okay, at the first 5 minutes, we will announce one number. 20 minutes, we will announce second number, and so on. So please pay attention. Okay, so without further ado, let's welcome Teacher Mawar.
Okay. Assalamualaikum and very good evening to all teachers and all the students. Okay, first, thanks to Teacher Kong as our today's moderator, and also Cikgu Shahnon as our control host, and Teacher Bibi Lau as our observer. Okay, so for today I will teach about predictable topic, but focus on group 2. And then, okay, before that, okay, I want to introduce. Okay, here is myself. Okay, here is a Kimia Prayu team. Okay, that conduct by KP is Cikgu Shahnon. Okay, so we have a mathematics team. Okay, conducted by Teacher Im. Okay, also we have a biology Prayu team. Okay, conducted by Cikgu Faizah. Okay, for physics team, okay, we have Cikgu Rosmaya. Okay, and then for perakaunan ekonomi Prayu, we have Madam Fizi. Okay, here is our topic today. Alright, it's the group 2, which is alkaline earth metal. Okay, for periodic table of element. Okay. So this is our syllabus for STPM syllabus. Okay, for group 2 we have 10.1, 10.2, 10.3. But I only conduct about B until E. So I didn't explain about anomalous behavior of beryllium because we need another 30 minutes if I teach about beryllium. Okay, so now. Okay, here is our periodic table. Okay, so I only focus on the group 2. Okay, alkaline earth metal starting by beryllium, okay, until radium. Okay, so now, okay, here is the beryllium anti-barium. Okay, basically for physical properties, when going down the group, okay, we can see that atomic size of group 2 increasing, okay, and its ionization energy is also increasing. Okay, since that we can see that the larger size of barium here make it the IE of the electron of the outer electron is a very lower, since it have a weakest attraction force between outer electron to the nucleus. Okay, so that during my lesson I didn't explain about radium, since the radium is below of barium. So if barium is the reactive one, so for sure radium is the most reactive compared to barium. We can assume that. All right. Okay, and
Hi,
then
Cikgu Mawar.
sorry.
Hi, Cikgu Mawar. What is the first number?
All right. So students, take note for the first number is 8. 8, number 8, number 8. Okay. So I continue for today's lesson. Okay, I only focus for these 4. For the first one is the reaction of group 2, which is it will react to oxygen and also to water. Okay, and then the second part, I will explain about the reaction of group 2 oxides, okay, towards water. Okay, and then thermal stability. Okay, for thermal stability, our syllabus is only include the nitrate of group 2, carbonate of group 2, and also hydroxide of group 2. Okay, and the last but not least is the solubility, which is for our syllabus, we only take a look for the solubility of sulfates of group 2. Okay, so now for today we just enjoy by I just giving more on animation lah. So they have not much about the chemical equation. So because it was so boring, is it? Okay, so now I started by the reaction of group 2. Okay, reaction of group 2 towards water. So this is the group 2. Okay, it's, starting by beryllium, magnesium, calcium, strontium, and barium. So this is the beaker which contain of water. So let we see the reaction each of the group 2 metal. Okay, starting by beryllium. Okay, when it dissolve in water, is it any reaction occur? So we didn't we can't see any reaction occur. So that means the beryllium we have to boil it. We must react it with a steam. Okay. All right. So for beryllium, when we dissolve in water, we must heat it, the beryllium, the water until more than 700 degrees Celsius, so that it will convert it into beryllium oxide and also hydrogen gas. So we can say that beryllium reacts slowly with steam. Okay, we take a look. If the beryllium oxide we dissolve further into the water, into cold water, okay, what happened? Any reaction occur? No. So that shows the beryllium oxide is the inert compound, right? So first thing that we can see, when beryllium dissolve in water, it will form first into beryllium oxide. Okay, we take a look for the second group 2, magnesium. Okay, we dissolve it in the water. Okay, so we can see that in the cold water, magnesium cannot dissolve in water. Okay, but when we boil the water, what happened? Yes, it's occurred the reaction. So for magnesium, okay, when we dissolve in the steam, okay, it will react rapidly. Okay, it will react rapidly to form magnesium oxide and also hydrogen gas. All right. Okay, now this is the chemical reaction involved. So this is student must know how to write the correct equation. Magnesium plus water, and we must heat it. Then it will form magnesium oxide and hydrogen gas. Okay, now let's say that we dissolve the magnesium oxide in a cold water. Okay, what happened? Okay, see, they have a reaction, which is when magnesium oxide we dissolve in water, magnesium oxide will react slowly to form magnesium hydroxide compound. So this is the reaction. Okay, and then what happened if this compound, this magnesium hydroxide, we heated the compound in a water. So what happened is it will convert back into magnesium oxide and water. Okay, so we can say this is the chemical equation. When magnesium hydroxide we heated, okay, we form magnesium oxide and H2O. So the second point for magnesium is when magnesium metal is react with water, So it will form with a steam water, it will form magnesium oxide first. And then magnesium oxide, when we further react into the water, then it will form magnesium hydroxide. Okay, that is the step that you must memorize. Okay, now we take a look for the third metal of a group 2, calcium. Okay, we dissolve it in water so we can see the reaction occur. Alright, so it will form calcium hydroxide directly. Okay, so it reacts slowly with a cold water. Okay, it reacts slowly with a cold water. Okay, how about strontium and barium? Okay, strontium, yes, it will form sodium hydroxide. Okay, and then barium, it also form barium hydroxide. Okay, so it react vigorously with a cold water. Right. So, what is the first summary that can we conclude? By the reaction of a group 2 metal towards water is, alright, when going down the group, the reactivity towards water increasing when going down the group. So, you can take a look for this lah. Okay, now, second reaction. Okay, we want to see the reactions of group 2 to oxygen. Okay, we want to see the reaction of group 2 to oxygen. Okay, before that, I'm show you that for beryllium and magnesium, when we dissolve with a steam, with a hot water, we can get the magnesium oxide first. Okay, and then we dissolve in water, then we can get the magnesium hydroxide, beryllium hydroxide. But for calcium, strontium, and barium, when we dissolve in water, we will get directly to its hydroxide compound. Okay, we dissolve in a cold water, we can get the hydroxide compound. Okay, so this is how to get calcium oxide, strontium oxide, and barium oxide. So this is basically the reaction involved of group 2 metal to oxygen. We will get the oxide group of a group 2. Okay, this is the chemical equation occur. Let's see that beryllium, when we react to oxygen, we will get beryllium oxide. For magnesium, when we react to oxygen, we will get the magnesium oxide. Okay, calcium, when we react to oxygen, we will get the calcium oxide, and so on. Okay, however, for beryllium, this is a less reactive. Beryllium is only can burn with oxygen if it is in a powder form. Okay, if we put it in a solid form, it can't react to oxygen. So we must put in a powder form. Okay, so for magnesium, when we react it to oxygen, so it will form a brilliant white flame. So you must memorize the color of the flame appeared when all the group 2 is burned into oxygen. Okay, the second one, when calcium is burned into oxygen, it will form a brick red flame. Okay, brick red, a brick red flame. Okay, to form calcium oxide. And then the third one, okay, strontium. Strontium, when we burn into oxygen, we will obtain the flame that color we call as a crimson red color. Crimson red flame is a light maroon lah. Dia macam like a maroon color lah. It's more darken. The red is darken red. Okay, so we call as a crimson color. So it will form strontium oxide. And then for the last one is a barium. Barium, when we react to oxygen to form barium oxide, it will appear apple green flame. So this is the kind of flame color of flame. Okay. So now, if you can see that here is how we want to get the calcium oxide, strontium oxide, and barium oxide. How to produce the calcium oxide, strontium oxide, and also barium oxide. We can react it into air, so we can get the oxide form. However, for beryllium and magnesium, we can get through oxygen, or we can get the magnesium oxide or beryllium oxide when we dissolve the metal into the steam, into the heated water. Into the heated water, beryllium, we must heat it into more than 700 degree, then we will obtain the beryllium oxide. and magnesium, we heated the water, we will get also the magnesium. Also, they have two types. We can obtain the both of the group 2. Okay, however, for calcium antibarium, we can get the oxide, okay, through oxygen, through oxidation. Okay, now, okay, we want to take a look the reaction, the reactivity of all the oxide of group 2 towards water. Okay, so we move to the second part, which is a reaction of group 2 oxide. Okay, reaction of group 2 oxide will include the beryllium oxide, okay, magnesium oxide, calcium oxide, strontium oxide, and barium oxide. This is I type it according to the size of the group 2, which is barium is the largest one, so it's easier for you to memorize the size. Okay, you know that barium is below 1, so it's a larger size. Okay, and then all right, now we take a look one by one how the compound of group 2 oxide is dissolved in water. Okay, starting by beryllium oxide, we dissolve it in water. Okay, have you seen any reaction? Okay, no. So that shows the barium oxide is inert in water. All right, the second compound, okay, magnesium oxide. Okay, we can see there they have a reaction, but it's quite slow. Okay, so it will form magnesium hydroxide. Okay, so what can we say? That magnesium oxide is react slowly. Okay, magnesium oxide is react slowly in water. So to form magnesium hydroxide compound. All right, it's a solid form. Okay, and then the third oxide. Okay, so for calcium oxide, when we dissolve in water, you can see that it will form calcium hydroxide. Okay, strontium hydroxide. Oh, it's very quickly. Okay, it directly form strontium hydroxide. Okay, how about barium oxide? Oh, okay, it's read directly. All right, so what can we say about calcium oxide, strontium oxide, and barium oxide is react readily in water. Okay, react readily with water. Okay. Okay, now, this is the summary for the second part, of the today's lesson. Okay, we can say that for beryllium oxide, to barium oxide, when it react to water, okay, we can say that the reactivity towards water increasing, going down the group. Okay, so they have 2 points now. The reactivity of beryllium towards water, the reactivity of beryllium to oxygen, and the second part is the reactivity of beryllium oxide to water. So that one is you must memorize lah. Okay, so now we have 3 types of group 2. Okay, the first one, we have a group 2 metal when going down the group. Okay, this is a group metal, which is we call as a alkaline earth metal. Okay, this is a group 2 metal. Okay, beryllium to barium. Okay, we also have group 2 oxide, beryllium oxide to barium oxide. Okay, this is we call as a group 2 oxide. Okay, also we covered in this topic of group 2 is group 2 hydroxide. When you dissolve all the oxide form of group 2 with water, you will obtain all this hydroxide group. Okay, we take a look back. Okay, so it will form all these things. It's all related. Okay, so how about the reactivity when going down the group? Okay, we can say that solubility in water increasing when going down the group. Okay, which is yang mana yang paling reactive? Which one is the higher solubility? For sure the below one lah. Okay, so then, okay, what can we conclude from this reaction is, okay, beryllium hydroxide, magnesium hydroxide, okay, is all the hydroxide. Okay, the important thing that you must know is all is the ionic compound lah. This is all the ionic compound. Okay, so for the first two of a group 2 hydroxide is insoluble. Insoluble, that's why insoluble. Okay, calcium hydroxide is sparingly soluble. Okay, why? For strontium hydroxide, barium hydroxide is soluble in water. Which you can see that the reaction is occur rapidly, is it? When you put in water, it's occur the barium hydroxide. Kan? Okay, and then, okay, what else that you must know in a group 2? Okay, is all the group 2, okay, either for group 2 metal, for group 2 oxide, and also for group 2 hydroxide, is all basic. Okay, for metal, you know lah, it's alkaline earth metal, alkaline earth metal. So this is alkali. Okay, and then for all the magnesium oxide, okay, anti-magnesium hydroxide, okay, sampai barium oxide and barium hydroxide is all basic. When we dissolve it in water, it will give the basic character. Okay, except the blue one. Okay, you can see that I bluing the two kind of compound. Okay, which is beryllium oxide and also beryllium hydroxide. Okay, these two compound is amphoteric. Okay, for in a group 2, only these two compound is amphoteric. Okay, so that's why we have a one subtopic which is we explain in detail about anomalous behaviors of beryllium. Okay, so for group 2, we have a beryllium which is the exception, which is not follow according to the other members' character. Dia lain sikit. Yes, the special character about beryllium. So that's why with all the members is basic. Okay, but for beryllium, it is amphoteric properties. Okay, for both. Tu yang you kena ingat lah. Okay, and then.
Hi, Cikgu Mawar.
Yes, Teacher Kong.
What is the second code for today?
Second code. Okay, second code is number 5. Number 5. Okay, students?
Thank you, Cikgu Mawar.
Okay. So now I have some question here. Okay, this is like a story, and you must know how to write the chemical equation. Okay, when exposed to air, calcium first forms calcium oxide. Okay, which is then converted to calcium hydroxide and finally to calcium carbonate. Write a balanced equation for each step. Okay, so which one is the, how many equation actually that you must write? Okay, biasa soalan exam pun dia akan bagi in terms of words, and then you must clarify, okay, how many equation that you must write. Okay, and then, okay, we have first, calcium first from calcium oxide. So that one is the first. Okay, first reaction. Second, converted to calcium hydroxide, meaning that calcium oxide, it convert into calcium hydroxide. They have two equation there, and finally from calcium hydroxide it formed to the calcium carbonate. This the question asked lah. So they have 3 of chemical equation, balanced equation that you must write. Okay, for the first one, okay, when exposed to air, okay, when you see this word, it's react with what? Okay, air. What is air? Okay, so air is refer to oxygen lah. So oxygen. So this is the oxygen. Alright, so this is the answer. So the calcium first exposed to air, which is oxygen, to form calcium oxide. Okay, so this is the reaction, the first reaction, and then you balance the equation. Okay, second equation is this calcium oxide convert into calcium hydroxide. Okay, try to remember. Okay, how all the group 2 hydroxide can be formed. Okay, tadi we dissolve it in water, is it? Okay, we dissolve in water and then we form the hydroxide compound. Okay, so means that this calcium oxide, we must dissolve in water to get the calcium hydroxide. Okay, so we write the equation like this. So calcium oxide react with water, we will get the calcium hydroxide. Okay, right. For this, okay, you can ingat one more thing is for the first product, we get 2 mole of calcium oxide, but the numbering is only used for balance for the first equation. Some student, I found that they take the 2 also, they put in the second equation. No needs. So you must know that the numbering is only for ratio, for balance the first equation. Okay, it's they don't involve for the second equation is lain. Okay, tak involve. So for the second equation, we just take the compound, which is calcium oxide. So we must started by 1 mole of calcium oxide, the new reaction. For write the new equation, we must take 1 mole of calcium oxide. We react with water, then we we form the calcium hydroxide, and then baru kita balance the new equation. Okay, the third one. Okay, the third one, when we see the product is carbonate, for sure that calcium hydroxide is react with carbon dioxide, because from carbon dioxide we form carbonate. And then also, if we heated the calcium carbonate, we will release the carbon dioxide. It will be related. When we see the carbonate, you know that either the reactant of the product must be carbon dioxide. Okay, same goes to hydroxide. Bila kita tengok they have hydroxide there, the reactant of the product must be water. Dia memang related. Alright, so for calcium carbonate to be formed, it must react to carbon dioxide. So it will form calcium carbonate and also water, because they have a hydroxide here. So it will form water here, and then you just balance the equation. Alright.
Hi, Cikgu Mawar.
Yes.
For the first equation, right? For KH alert, the calcium should be 2. For the first equation, 2 calcium solid.
Yeah, correct. Sorry. I don't know I can write or not. Okay, so this is a 2, Okay, alright. Sorry, it didn't balance yet. Okay, it's because I just added just now before started the class. I just wrote the question. Okay, alright. So 2 more of calcium react with oxygen, so it balance already. Okay, alright. So and then the everything okay. Alright. Okay, and then we move. Alright, so we want to move to the third one. So is it we want to rest first, or I just continue? Teacher Kong?
There is another 3 minutes.
Another 3 minutes. Okay, I just go on for the thermal stability. For our third part, our third part for today's lesson is the thermal stability. Okay, for thermal stability. Okay, for thermal stability, for our syllabus, we only involve of a group 2 nitrate, group 2 carbonate, and also group 2 hydroxide. Okay, so this is the compound of nitrate, carbonate, and hydroxides. Okay, M is represent group 2. Okay, when we talk about thermal meaning we give them strong heating. Okay, we heated them, we heated the compound. Okay, when we heated the compound, okay, what you must know that from the carbonate compound, the first thing it must appear 1 mole of carbon dioxide gas. Ada satu jenis gas saja yang akan form, yang akan release, which is carbon dioxide. Okay, which is colourless gas lah. I nak buat colourless, nanti I takut that kita tak nampak lah I bold here kan. So I just put like the warna langit tu lah. Okay, so from carbonate, we form carbon dioxide gas and also group 2 oxide. Okay, for the second one, we have group 2 nitrate compound. Okay, nitrate. When we write the chemical equation of nitrate, it will form 2 types of gas will be appeared. Okay, the first one is nitrogen dioxide gas, which is brown fumes. Kita akan nampak that this is like a brown fumes released in our test tube. Okay, and then we also have oxygen gas, okay, which is the colorless gas. So for nitrate, when you write the chemical equation of group 2 nitrate, it must release 2 types of gas, nitrogen dioxide gas and also oxygen as well. Okay, so the other product is also group 2 oxide lah. Okay, and then the third one that just I doesn't talk for the earlier class, for the earlier before that group 2 hydroxide, okay, it will form water. Okay, it will form water, and also for sure that group 2 oxide. Okay, this is the basic equation. Okay, all the student must know when you involve any compound that involve of nitrate, carbonate, and hydroxide. This is already covered in the SPM syllabus. You already learned it in a form 5. Okay, I'm sure that for you to know about this. Okay, you must keep writing this. Okay, and then okay, what else? Okay, so on strong heating, you can see that all the carbonate, nitrate, and hydroxide compound, it will decompose to oxide compound, oxide of group 2 compound, which is this shows that MO, which is oxide compound is energetically more stable. Usually bila dia form another compound, which is that another product, which is that product is more stable lah daripada its reactant. Okay, we must A plus B form C, which one is energetically stable? For sure is a C, which is occurring exothermic. So for sure that the product is a stable one, the most stable one. So for this, magnesium oxide or beryllium oxide or calcium oxide is more stable than its nitrate compound, than its hydroxide compound. Okay, and then, all right. Okay, when we talk about thermal stability, they have two keywords that you must take note. Okay, bila dalam exam, when during you doing your exercises, you see the keyword of stability, thermal stability or thermal decomposition. Okay, they
Hi,
have
Cikgu Mawar.
Yes.
Before we proceed these two terms, right, let's stop for a while for
Yeah.
advertisement. Thank you.
Okay, see you.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Let's continue our lesson with Teacher Mawar.
Okay. Welcome back, class. All right, so now, okay, and like I said earlier, okay, for thermal stability, we will find the key about the keyword of thermal stability or thermal decomposition. Okay, that one is the same thing but different. Okay, we can see that for hydroxide compound, when it decompose into MO, into oxide compound, so we can see that this is the thermal decomposition. So this is decompose to the stable product one. All right. Okay. So when we talk about the thermal stability, thermal decomposition, actually, okay, the example I give here, magnesium hydroxide. So actually, it involves the ionic compound, which is that we have ionic compound, then we want to break the ionic compound into its ion. Alright, into its ion lah. So we want to see how the stable of the ionic compound, how the easier the magnesium hydroxide to be decomposed into its product. So that one, when we talk about stability, when we talk about decompose, so we want to break them, break the ionic compound, so that for your answer, okay, first we write the magnesium hydroxide. Okay, for your answer, we must write the term as a ion. Okay, let's say that bila kita ada magnesium hydroxide, to answer the thermal stability, to answer the thermal decomposition, we must take note that we must write down the magnesium ion, hydroxide ion. We can't write as a magnesium hydroxide. We didn't mention about ion, then we akan dapat salah lah. It's wrong. We don't talk about the atom. We talk about the ion. Okay, the ion in the ionic compound. Okay, that one is the first thing when we answer the thermal stability or thermal decomposition. Okay, and then when we talk about ionic compound, for sure that we have cation here and also we have anion here. Okay, we have cation, we have anion. Okay, so for cation, okay, the keyword that we must include in answering the question involved of stability, thermal stability and thermal decomposition of group 2. Okay, group 2, I mentioned that one is a group 2. Okay, because we also have thermal stability of group 17. But this one is a thermal stability of group 2. Okay, keyword is for cation. We must write down the polarizing power or charge density. These two keywords that must you write in your answer. Okay. Okay, for hydroxide ion, okay, the keyword is polarizability. So this is the keyword when you want to explain about anion. Anion, hydroxide ion. For this case, it's a hydroxide ion. Okay, so now, okay, for cation, for anion, because we talk about thermal stability of ionic compound, so we must take a look about the cation, about the anion. So for cation, when we going down the group, okay, for starting for beryllium ion to barium ion, okay, you can see that for the this one, okay, from below to upper, okay, from barium to beryllium, okay, we can see that the higher charge density, because how to measure the charge density? Okay, charge over ionic radius. Okay, so beryllium, okay, beryllium, you know that is positive 2 lah, charge over ionic radius of beryllium. You know that one is smaller size. So for sure we got the higher charge density. Alright, and then, okay, what can we say? That beryllium have higher polarizing power. Its power to attract its anion. Okay, this one is a cation, this one is anion. Anion, you know that is occupied by electron tau. Outer it have too many electrons. So electron even moving. If it attracted, it will polarize by cation. This cation have a power, polarized power. Hanya group tu cation only will attract, will polarize the anion toward themselves. Okay, so when this occur, the polarizability occur means that this compound is less stable. Okay, less stable lah because attraction occur. Okay, so same goes to the anion. For anion, okay, for anion, okay, going down the group, from oxygen, okay, we have oxygen ion, oxide ion, we have hydroxide ion, we have a nitrate ion here, we have a carbonate ion here, and also we have a sulfate ion here. This is the anion types according to size. Okay, I already arranged according to size. So what can we say that for the larger size, which is sulfate ion, okay, it have a higher polarizability. So for sulfate ion is less stable lah because dia ada banyak electron. So that it easier to be polarized by cation. Okay, let's say this one what we call is a polarized, which is kalau strontium. So strontium is easily to polarize the carbonate ion towards itself. Dia akan attract electron towards itself. Bila ini berlaku, this shows that this compound is less stable. Less stable lah sebab berlaku attraction. Kalau dia stable, dia tak akan berlaku lah. Okay, then okay, this is the thermal stability and thermal decomposition. Let's say I give example. Example here. Okay, magnesium hydroxide and magnesium carbonate. Compare the thermal decomposition of both compound. Which one is more stable? Which one is less stable? Magnesium hydroxide and magnesium carbonate. So how to write? Okay, first you write down the equation, the formula. Okay, the compound. Okay, and then this is the table. Okay, usually I write this kind. Okay, and then for cation, don't forget that when we talk about thermal decomposition, for cation, the keyword is polarizing power. The anion is polarizability. Okay, now we list down each ion from the compound. Okay, you keluarkan. Okay, for magnesium hydroxide, we have magnesium ion as a cation, hydroxide ion as an anion. Okay, and then magnesium carbonate, magnesium ion, and also carbonate ion here.
Hi, Teacher Mawar.
Here.
There is one question from student.
Okay.
Polarizability is the same as polarizability?
Polarizability.
Oh, I think he is asking polars. Okay, you look at the screen now. I think he is asking polarizability and the polarizing ability, maybe.
Polarizing ability. Wait, I must see from the chat. Polarizability. I think this is spelling, is it? Polarizability.
I think he asked the previous slide.
Yes. Oh, okay. Is it same? You just take note for the. You just looking for the correct spelling. You just about the spelling lah. Okay. Polarizability. Okay, and then okay, common ion. Okay, and then that one is you can see that both according to the cation, you can see that both are magnesium. So we can say that it shares the common ion. So the comparison cannot be made by cation since it shares the common ion because it's sama. So kita tak boleh nak compare according to cation lah. So we take a look for the anion. We just compare according to anion because it's a different. Okay, so for hydroxide and carbonate, okay, take a look for the size. Okay, carbonate here, hydroxide here. Okay, so you know that carbonate is a larger size, is it? Okay, so what can we say that carbonate ion is a larger ionic size compared to hydroxide ion? Okay, what happened? How about the polarizability? How about the polarizability of both ion? Which one is higher polarizability? Is it carbonate or hydroxide? Okay, since carbonate have a higher, larger size of ionic size, so it have higher electron, is it? Okay, so carbonate ion has higher polarizability than hydroxide ion. Okay, and then okay, carbonate ion is easier to be polarized by magnesium because magnesium is have a polarizing power, is it? Dia yang ada power nak attract, nak polarize anion. So carbonate is easier to be polarized. Oh, easier lah nak polarize. So is it stable or not? Okay, so we can say that magnesium carbonate less stable than magnesium hydroxide because carbonate easier to be polarized. So it's less stable. So what can we conclude? That hence, magnesium carbonate less stable to heat and easier to decompose to magnesium oxide and carbon dioxide. Okay, so we take a look for the second one. Calcium carbonate and calcium nitrate. Okay, we have
Teacher Mawar. Before we
yes.
proceed for the next, let's announce the third code number.
Third one Third one is a 8. Okay, 8. Okay, the third code is a 8. Okay, student. Alright, now okay, for calcium carbonate, just I said earlier, okay, just you just keluarkan all the ion. Okay, we have calcium ion, we have carbonate ion as an anion. For calcium nitrate, we have calcium ion, nitrate ion, and then you can see that it still share a common cation. So we must answer according to the anion. We must compare according to the polarizability. Okay, for polarizability, we must see the larger size have a higher polarizability. So once again, carbonate here, nitrate here. So carbonate is a larger ionic size. Okay. Then it has higher polarizability. It's easier to be polarized and less stable. Okay. When you want to compare the stability, don't forget to write the full compound. Jangan kata that carbonate is less stable than calcium than nitrate. No, wrong. When you want to compare the thermal stability, you must mention the full name of the compound. So calcium carbonate less stable than calcium nitrate. Okay, and then this is the answer. Okay, the third one. Okay, you must faster. Okay, magnesium nitrate and strontium nitrate, and then you must compare the thermal stability of both. Okay, now if you can see that it share the same anion. Okay, so you must compare the thermal stability according to polarizing power of cation. Okay, so you just write down the ion involved of both compound. Okay, now nitrate, since it share the common ion, so we just compare according to the polarizing power. So for cation, okay, which one is kita nak tengok that siapa yang ada higher polarizing power. So for sure the smaller size because how to measure the polarizing power? Charge over ionic radius ni, charge density. How to measure the charge density? Charge over ionic radius. So that magnesium and strontium, magnesium have a smaller ionic size. Okay, so what can we say? Magnesium is higher polarizing power than strontium. Okay, which is magnesium is also have higher charge than Ct. Okay, and then magnesium is easier to polarize nitrate toward itself. Okay, so for magnesium nitrate, it's easier to polarize the nitrate to itself. Okay, finally, we can compare the stability. Okay, magnesium nitrate less stable to heat compared to the strontium nitrate. Okay, also we can say that magnesium nitrate is easier to decompose into nitrogen dioxide and oxygen. Okay, and also magnesium oxide. Okay, also can put that lah as answer. Okay, now we go to the question. Okay, student, ready to answer the question. Number 1. Beryllium hydroxide decomposed to beryllium oxide when heated to 138, which statement explain why beryllium hydroxide decomposed at such a temperature. Okay, what is the keyword here? Is decompose. Ingat tadi, bila kita mention about decompose, apa keyword? Dia kadang-kadang bila kita nak all the answer is right tau. We have a right answer, but which one is the accurate answer? So bila we talk about decompose, what is the keyword? Decompose, ingat So bila kita sebut decompose or thermal stability of group 2, you know that beryllium is a group 2. So the keyword dia mesti ada either polarizing power, kalau you nak compare the cation, hydroxide we have a polarizability. Okay, so also charge density for cation. So which one is the correct answer? Ada answer tak, Teacher Kong?
For the time being, no.
For the time being, no. Okay, so the answer is for sure that we know that beryllium ion is very small compared to the other, but it's not the accurate answer, because when we talk about decomposition, we talk about the thermal stability of group 2. This all the main keyword that mesti ada dalam answer. So dalam ni is didn't explain about polarizing power or polarizability, but it have a charge density. Charge density is relating to the polarizing power lah. So we can say that beryllium ion has higher charge density. Okay, that one is the answer. How you want to tackle the answer in an objective question. Okay, now the decomposition temperature for magnesium carbonate, we have calcium carbonate and strontium carbonate is like this. Dia punya ni. Okay, the factors that explain the variation observed above. Okay, apa keyword yang kena ada? Yang ni you tengok tak? Decomposition. Decomposition of when you see the compound, oh this one is a group 2 ni. Group 2 kan, magnesium, calcium, strontium. So that we talk about the decomposition of group 2. So what is the keyword? Okay, you see. They share the common anion, semua carbonate. So you must explain in terms of cation. So tadi apa keyword yang kita kena ada bila kita explain about cation? Okay, what is the keyword? Cation. Okay, apa yang kena ada bila kita explain about cation? Is it charge density and also? Okay, also what? Okay, can you get me, student? Okay, so we have a polarizing power. Okay, remember for group 2 decomposition, okay, when we want to compare according to, okay, kita kena tengok lah, oh ini because of it share the common anion, we cannot compare according to anion lah, according to polarizability tak boleh because it share the common one.
Cikgu Mawar.
Yes?
Ada seorang budak Justin Chai answer D.
Okay, polarizing power of cation. Okay. Let me see the answer. Yes, correct. Okay, good. Very good, student. Okay, so because we talk about the difference of cation, so bila kita explain, we must put the keyword is a polarizing power. Okay, yang tu je. Yang ni is quite confusing, but sebenarnya is very easy. You nak kena tahu. You kena tahu tackle the question. Okay? Okay, then, okay, we have a next question here. Okay, an element of group 2 in periodic table react with cold water. Ingat tadi, it react with cold water to produce a product which has the highest decomposition temperature. Okay, highest decomposition temperature. What is the element? Okay, tadi you ingat that group 2, bila I dissolve it in water, okay, the first one, the first dissolve in water tadi, beryllium cannot react, it's inert. So it's not beryllium. Okay, and then magnesium. It can react with cold water. Student, tadi lagi tak? Kita kena guna api or not? Okay, we must heat it, is it? So it's also not magnesium. So the answer here is maybe calcium or barium. Okay, so keyword dia tadi cold water. Cold water, you know dah tadi, I dah tunjuk dah dia punya dissolving in water tadi. Beryllium and magnesium, we must heat it. Okay, kita kena guna steam water baru dia akan react. Okay, A and B out. Okay, second keyword is highest decomposition temperature. Okay, highest decomposition temperature tau. Highest decomposition temperature. Temperature yang paling tinggi untuk dia nak decompose. So which one dia nak stable ke dia nak less stable? So you can see here. Okay.
Hi, Cikgu Mawar.
Yes.
Okay, student answer, is it donkey? B?
Donkey, barium. Okay, any other answer? Only one answer. Okay, so they want to the stable one lah because it want to the highest decomposition temperature. Highest temperature meaning that kita kena panaskan dia lama baru is dia decompose. So that one is kita nak which element yang higher stability, more stable. So for cation, like I said that kalau dia higher polarizing power, dia less stable lah sebab dia senang nak polarize the anion. So the answer is correct, student. Okay, so the answer is barium. Very good, student. Okay, now, okay, magnesium hydroxide is thermally more stable than magnesium carbonate. Okay, which is true about this statement? Okay, yang mana yang betul about this statement? Okay, once again, the keywords is what? Okay, first thermally stable, thermally, and then we have a group 2, magnesium hydroxide, magnesium carbonate, that one is group 2. So group 2, when we talk about the thermal stability, okay, you must compare either cation or anion. So from this question, it shares the common cation, both are magnesium. So you must compare according to anion, hydroxide and carbonate ion. So what is the answer? Okay, another keyword, another key that I can give is ionic size. Maybe some of you is not memorized the size, is it? Okay, so according to hydroxide and carbonate is the larger size compared to hydroxide. So what can we conclude? Okay, any answers from student?
For the time being, no yet. Just wait for a while and see.
Okay, so actually you can see lah, ingat lagi, what is the keyword? When we talk about the thermal stability of group 2, we must have polarizability, we must have charge density, we must have polarizing power. Any answer that involve these 3 keyword, that one is the correct answer. Okay, sebab because yang lain tu is actually is correct juga, is betul juga, tapi is kita nak the accurate one. Okay, hydroxide ion is the bigger, salah. Okay, hydroxide ion is less polarizable than carbonate ion. This one is the correct correct spelling, polarizable. So tadi maybe I wrong spell lah, polarizability. Nanti you betulkan lah, polarizability. A there. This one is the correct spelling. Okay, and then enthalpy or formation is more negative than magnesium carbonate. From group 2, we didn't mention about enthalpy of formation at all. Okay, and then the ionic compound is stronger than, we talk about the ionic bond here in our story of today's lesson? No, is it? So the correct answer is?
Teacher Mawar, there's answer from student B.
Yes, very good, student. So the answer is B, correct, because we talk about polarizability for anion. Okay, so hydroxide ion is less polarizable than carbonate ion. All right. Okay, now we have another 10 minutes, is it? Okay, so for my last is the solubility. Okay, now. Okay, when we talk about solubility is refers to sulfate. Refer to sulfate only tau. Okay, so we have beryllium sulfate until barium sulfate. What we can say that when going down the group, okay, it's less stable when going down the group 2. Okay, so the solubility is beryllium and magnesium is a soluble compound. Okay, calcium sulfate is a sparingly soluble, while for strontium sulfate and barium sulfate is insoluble. Why? Ini dia terbalik tau. Is different to the hydroxide of group 2. Ingat, group 2 dia lain, di bawah yang more soluble. But for sulfate is different. Okay, why? Okay, so this is the explanation. Okay, when we talk about solubility of sulfate, solubility of group 2 sulfate, dua keyword dia yang you kena tahu is lattice energy and also hydration energy. When we talk about lattice energy, we refer to the compound. lattice. Okay, apa maksud lattice? You already learned in chapter 1. Okay, energy release when 1 mole of compound is formed from its constituent gases, ion, under standard condition, and so on. Okay, the keyword is 1 mole of compound is formed. So when we talk about lattice energy, we refer to the compound. Ingat, dia mesti kena ada anion and also cation. Okay, so more negative, which is more exothermic, the more stronger the ionic bond. Okay, more negative, more stronger. Okay, bila lattice energy dia tinggi, means that dia reversible to the solubility. So solubility is inversely proportional to the lattice energy. So bila lattice energy tinggi, means that it's less soluble. Okay, the second one is the keyword dia ialah hydration energy. Okay, what is hydration energy? 1 mole of gaseous ion is completely hydrated by water molecule. So meaning that hydration energy is referred to the dissolving of ion into water. Dia nak form bond dengan water molecule. So dia akan higher solubility lah. So we can say that more negative or more stronger, the ion dipole forces between ion to the water molecule is more soluble. Okay, so solubility is directly proportional to the hydration energy. So we can say that the smaller size of ion have higher hydration energy. Okay, so why? For the greater lattice energy, because the larger size of barium, so you have a greater lattice energy. So we can explain this, okay, we using the graph. Okay, for the graph, we can see that when going down the group, lattice energy decreasing as well as hydration energy. Both are decreasing tau bila going down the group. So, okay, but what can we say that? Okay, lattice energy is decreasing slower. They're decreasing slower because the magnitude only depends on the ionic size. Ionic size of beryllium plus dengan sulfate ion. Dia kena plus dua-dua ni. Because lattice is talk about compound. Dia kena tambah dua-dua ionic size. Okay, kalau hydration energy, it decrease more rapidly than lattice energy because it's only increasing according to the beryllium, magnesium, calcium is only one ion saja. Kalau if we want to talk about hydration energy of cation only. If we want to talk about the hydration energy of anion only. Okay, we didn't miss out with the other cation or anion. Okay.
Hi, Cikgu Mawar.
Yes.
What is the fourth number for the passcode?
Alright, for the last code is the number 2. My favorite number is number 2. Okay, and then, alright, how to explain it easier is you imagine that this box is a sulfate. This box is a sulfate. Okay, the box is 100 gram. Okay, when this is an ants. The black ant is a cation, is a beryllium ion. Okay, the red ant is a magnesium ion. Okay, if kita nak compare the size of ants, we can compare lah because maybe yang ni berapa dia punya size? Maybe berapa? 10 times of 10 power of 3, negative 3 size je kan. Okay, and then we can compare to the another ants lah because dia punya decreasing dia is very rapidly different. But if we compare, example okay, example we nak weight the box with other ants, black ant dalam atas tu. You rasa when you weight dia, is it there ada increasing difference? Is it dia akan jadi 101 gram bila kita nak measure dia? Because ada satu ants masuk dalam box ni. So for sure lah, it's remain the same. When we weight the box, it still lagi akan jadi 100 gram. Because it's a very large kan, very different. It's not related because it's smaller, very smaller size of ants. We cannot weigh it. Okay, when we put in the box. Okay. How about if we put the red ants into the box? Is it ada any difference of the punya weight dia? It's also same. We will still get the 100 gram. So same goes to when we measure the beryllium sulfate, magnesium sulfate, calcium sulfate, strontium sulfate and barium sulfate. Because sulfate is a very large size. Sangat besar size dia. Bila kita nak tambah with the beryllium size, it's like macam kita tak tambah pun because the size is very smaller. Okay, the cation size is very smaller size. maybe akan jadi 100.001 gram because it's a very smaller size of cation. So that's why we can see that when the lattice energy is decreasing, it's only decrease what we call is only decrease slower. Okay, lattice energy is only decreasing slower because sulfate is too big when we want to add it with a size of cation. So kalau hydration energy, we only add it to the beryllium ion. We nak compare dengan magnesium ion, so it very larger difference lah. That's why kita kata that decreasing rapidly. So what can we conclude here is, okay, if hydration energy is greater than lattice energy, meaning that the compound, the sulfate compound is soluble. Let's say that kalau kita letak kat sini strontium sulfate, so because of dia punya lattice energy of strontium sulfate is greater daripada hydration, so that is easier lagi nak form compound. So dia akan jadi insoluble. Okay, when lattice energy is greater than hydration energy, this compound would be insoluble. So refer to the strontium, to the barium sulfate, because lattice energy is greater than hydration energy. Alright, and then okay, ini I just nak buat summarization for the whole topic today. Okay, you must know that when going down the group, reaction of group 2 towards water increasing, and then what is the kind of the flame color for oxygen? Okay, and then for reaction of group 2 outside with water, okay, dia punya ni akan increasing. Okay, how about the thermal stability? When we compare to the cation, you know that it's from lower to upper is less stable. Okay, which is beryllium is very smaller size, higher polarizability and less stable. Okay, and then in terms of solubility, when going down the group, we can say that it's less soluble. So barium sulfate, strontium sulfate is insoluble. Calcium sulfate is sparingly soluble, and these both upper of sulfate compound is soluble. So ini you kena tahu. Bila kita nak explain about solubility of sulfate, ada dua keyword, lattice energy and hydration energy. Okay, and then okay, so maybe it's the last question kot. Okay, beryllium sulfate and strontium sulfate have different solubility in water. Which statement explains the difference? What is the difference? Okay, we talk about the solubility. We talk about the solubility. Okay, again, beryllium sulfate and strontium sulfate, soluble. Beryllium sulfate is soluble, strontium sulfate is insoluble. So what is the conclusion? Ingat, bila kita explain about solubility in water, for the sulfate of group 2, dua je keyword. Kita nak explain in terms of hydration energy, or we want to explain in terms of lattice energy. Yang lain-lain kita tak payah tengok dah. So A and B is out. Okay, maybe it's correct but it's not accurate. Okay, so kita tengok C and D. So ingat, okay, when we talk about that, dia kata apa difference dia? Okay, strontium is insoluble. Meaning that bila dia insoluble, lattice energy dia is greater. Lattice energy is greater than hydration. Lattice energy. So, lattice energy is more negative than beryllium hydroxide. More negative meaning that is more ni lah, okay, higher lah, is more higher. More negative bagus lah, dia more higher. Lattice energy is more higher. Okay, so the correct, yang ni hydration. Okay, it's more negative. Okay, because dia kata beryllium. Okay, correct. Because beryllium. So yang ni is strontium is more negative. Okay, salah. Yang ni betul, hydration. Because dia more negative, hydration is more negative. Hydration is more negative. Okay, meaning that dia akan lebih dissolve in water. Okay, hydration meaning dia akan form bonding dengan water molecule. So donkey is correct answers. Okay, ni last. Okay, but not least, ini you boleh tengoklah nanti what is the kesimpulan that we can say for the whole topic. For group 2, which statement is the correct one when going down the group 2, this is the summary, the summary. So you can answer according to this. So nanti you just tengok balik, kan, you can answer this. Which one is the tepat, yang paling accurate is the B, charge density. Okay, according to this note je, ini is the summary of a group 2. Okay, I think that's all, Teacher Kong, because we all run out of time.
Okay. With God grace, we are done with today's section. We have learned a lot from Teacher Mawar about periodic table group 2. Congratulations to those who are here with us, follow this section from the beginning to the end. And thank you very much, Teacher Mawar, for the such an interesting lesson. Please check the chat box for the certificate link. Okay, don't forget to click the bell button too, so you won't miss out any new video and live classes from Teacher Mawar. If you like today's class, then please click like and share it to your social media friends. Let's share the knowledge you received today with them. Sharing is caring, right? When you have finished, type done in the chat section. Then I will give the cert link again. Okay, once again, I would like to thank you, Teacher Mawar, for the interesting lesson. Thank you also to Teacher Vivila and Teacher Shannon for being with us today. I think that's all for now. See you in another section. Please do remember, stay at home. Goodbye, everyone. Have a nice weekend. Bye.
Bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.